Hello, my name is Spencer Sheen, and this is going to be a live coding video. My intention here is to create a population density map along the banks of the Seine River in France. This is not so much a tutorial, so I'm not going to take it easy on you as I walk through my process. I intend this to be more of my normal process, how I usually create these maps. I have some shortcuts. I have a foundation that I've built. But I think that'll be informative for people too. So let's go ahead and get started. If you are aware of these maps I've been creating, you might know that I have a project set up for them, a GitHub project, or a GitHub repo actually. It's called Ray Shader Portraits, and my username is Peckners, so Peckners/Ray Shader Portraits. And I have this repository that has all my code to create these graphics. And so you can see I've been doing different types of population density maps lately. Like I said, I want this one to be the population density along the Seine. And so it would be something a little bit like this, population density along the Amazon River. I also have one of the Nile. So something like this. Okay. So to get started, I'm going to open up my Ray Shader Portraits project in R. I'm going to go ahead and clear everything. Make sure I'm in my... Okay. So the way that I have this repository set up, it's not its own package, but I have some custom functions that I've included in this project. For instance, here it says use new portrait to start working on a new portrait. So this is a function that I've created, and I include it in my R profile. So I can do this new portrait, and I'm just going to call it Seine. Well, shoot, I messed up actually. And this is the only annoying part. So you can see it created this folder, but I'll show you that in a minute. What I messed up with is this function has a template argument, and the default is set to an elevation map for shaded relief maps that show the elevation of an area. I don't want that template. I want to use my population template, population density. So there. So now what that function does for me is it creates a subrepository, a new folder here that is named whatever the name that I pass it, and it fills in certain variables on this page that are just helpful to me. It's not going to be helpful in this instance because you can see here I have the template here by default includes information to get US state geographies. We're not going to need that. But anyway, that's just a little background on what this, how that function creates. It uses templates, so I don't have to start over coding from scratch each time. I can start with the basic script. And an alternative to that would be to create just individual functions that would do all of this for me, since I'm largely just recreating these. But I find that I like to that I make enough edits to some of these areas that I don't want to do that. I'd rather use the templating mechanism that I have built here so that I start with this default script. So I'm just running through these basic libraries that I install or that I use for most of these scripts. This data file is If you're unfamiliar with the contour population data, this is the US data. That's what this US means, so the United States. And of course, since it's the Seine, we will be looking at France. So I need the French data. And I've already downloaded it, but just to quickly show you how you can use it, you can go to contour.io, click use for free. It takes you here. If you read this, per country subsets are available at this link. So let's go here, search for France, and there's your France data. So you could download this. But I already have it downloaded, like I said, so I can go ahead and load it using the stread function. And there we go. Okay, so I am usually doing United States state population density here. That's why I have this as the default. But that's not what I want to do. I want the river Seine, and a good package, a good R package that makes data like that available is called R Natural Earth. And let's see if I can remember. How this works. So any download, I need to look this up. So any download provides a lot of different data, or it could provide a lot of data, but I want rivers, lakes, center lines. Okay, and so that will be the type here, I believe. So type equals, well, first of all, I want good scale. I want it to be detailed, so I want the scale to be large, type to be river, lake, center lines, and I want the return class to be SF. Let's see if that works. Ooh, that is a lot of information. All right. Whatever. I will deal with the download, I guess. Okay, so it's giving me a shapefile. All right, so I'm copying that over to my data file, and I'll drop it in here. In general, the large data files will create issues if you're tracking them. So let's add it to our get ignore any 10 meters. So the data any 10m star. Okay. Now let's do st. First of all, let's call this rivers, stread data slash 10 any 10m. What is this file called? Rivers, lake, center lines slash any 10m rivers, lake, center lines dot shape. And of course, I spelled it wrong. Rivers. Okay, there we go. Now, glimpse rivers. Because I need to find, okay, name. All right, so let's try. Seine is rivers, filter, name equals Seine. Heyo, that worked. Well, would you look at that? Now the final check I want to make is that the Seine is completely inside of Paris or of France. So I need French countries. So I need the French shapefile. Okay, so this countries 110 argument is coming through as an SP class, but I want it as an SF class so that I can easily filter it for admin equals France. Okay, FR, let's save that to the FR object. geom.sf. Data equals FR. See what that looks like. Okay, there we go. So this is a really ugly map, but yes, the Seine is completely inside of France. I'm still a little not confident about that. So the Seine is a river in France. Let's just make sure. Let's confirm this information for me. All right. Good enough for me. Okay. So the reason I want to confirm that is so that I know that all of the river will be encompassed by this population density data, because the population density data is limited to France. So now we, okay, so this next code chunk, first we need to create our buffer along the river. Let's call it Seine buff is st buffer Seine. This st buffer is based on the units of the CRS. So here I'm going to examine the CRS of the Seine. And these are in meters. One more thing. St transform. Actually, here, I'll do this down here. I need the Seine and the data here to be the same CRS. So instead of doing that, I'm going to say st transform Seine CRS equals st CRS data st buffer. And let's check the stCRS of the data. Let's check the CRS of the data just to make sure. This is also in meters. Okay. And let's buffer it, let's say 25 kilometers within the river. And now let's look at what that looks like. Oops. Okay. That is what we want. So now we've created our buffer. Now we need to limit the data to whatever is covered by this buffer. Now, this code chunk that I have right here, I've since learned that I'm doing this backwards. So if I do st intersects, this will return a list that tells me which elements intersect with the two geometries. So for instance, for our data element has 620,000 observations. Those are each the individual hexagons that make up the contour data. There are 400-meter hexagons that the population is bucketed into. And so what st intersects will tell us is for each of those hexagons, does it intersect with this area? So that's what I want to do here. So first we're going to say send buff. So it's going to take this argument and then it's going to iterate. I might be getting this backwards. Let's see. Okay, no, that's right. So it's iterating over each element of data, each row of data, so each hexagon, and it's indicating which rows do in fact intersect with this geometry that we've defined here. So this is not correct anymore. But this is... So what we want to do here is filter the data for the rows in int. So if I'm to do this, for instance, then that will return this element that tells me all of the hexagons, the index for all of the hexagons that fall within this area. So I'm just filtering the data like that. All right, now we are cooking with gas. So here, this is just setting up my boundaries for the raster I'm about to create. I talk a little bit more about what I'm doing here in my other tutorial video. Check that out if you want to see it. I don't want to use these colors actually. Equals Met Brewer. There was another Met Brewer palette I wanted to use. What was it? What was it? What was it? What was it? Tam. Okay, and I want it to go that way. 4 is kind of a lot, don't you think? Well, let's see how that does us. Ooh, looking pretty cool. Pretty cool. Do you see Paris? Okay, 45. Let's see what that. Ooh. For the river, I don't think I want to spin it at all. I'm going to reduce the exaggeration there a little bit. There we go. That's a little better. Now, what angle do we want to view this at? It's a little difficult because Paris is going to block out everything. Let's call it 60. The reason I don't, I keep this at 0 is because that controls the rotation like this. Whereas if I have it at 0, then the north-south axis is maintained. It's the normal north-south, so up is north. And if I change it, then now north is like that way. But I need to, like for anyone viewing this map, that would just be confusing to them. So I try to, for a river, I try to maintain the north-south orientation. But even as I'm saying that, I'm wondering, is that totally necessary? Well, let's see. Okay, so here, these are just some utility functions. I'm creating a directory for the object, for the image that's going to be created. Here I'm setting the file name for that image. I'm saving an RDS file, an RData file, with some basic information about this plot that I'll be able to use with the when I'm marking it up later. And then this code chunk is the high quality render. This will take a long time when I'm ready to do it finally, but for now I'm going to make it smaller. I'm going to do fewer samples, making it only 800 by 800 instead of 8000 by 8000 pixels, so that this will render quicker. Because right now I'm just building. I want to be able to iterate more quickly, so that I can decide on the lighting and all these other elements. Okay, that took about a minute to render. Now, if I go in here, here's my render. Like I said, this is not nearly as high. The resolution is much lower than I'll make it in the end. And you can really tell if you zoom in how bad the resolution is. But this is good enough to give us an idea of what the lighting looks like, and how we have the whole thing oriented. Actually, I like this. I think this is pretty good. I do want to change this lighting angle. Okay, so we have it coming in at 140 and 150. What if we had it coming in at 40 and 50? I turn preview equals true on so that I don't have to wait for the render to finish. When preview is true, then there's going to be a window that pops up and it shows me the render as it's compiling, or as it's rendering. And so when I do that, I won't have to wait the full minute for it to render, because I can already see the details of this. I'm still unsure about this though. The thing I'm unsure about is when we have the lighting coming from an angle that casts a shadow on the side we're looking at. So the shadow's over here, which means the colors aren't as bright. They don't pop as much. And it's just duller. So let's add 180 degrees. So let's flip it directly around. So 40 plus 180 would be 220, 220, 230, 230. And the reason that I do these 10 degrees apart is just so that I get that slight offset of the colors. I think that's kind of neat. Another thing is this is kind of dusky lighting. So you see I have these white lights where the intensity is pretty low. So we can increase that. Let's double that. All right, now let's see what that does for us. I think it's really going to pop this time. But let us see. Ooh. That is pretty cool. Man, it almost makes me wonder if it's too much. That is, because Paris really just sticks up there, doesn't it? Oh, man. Oh, man. Well, I think I think we're good with this. I think we'll see how she goes. All right. So a couple things. First, I realized I didn't change this palette to the correct name. So let's do that. Also, let's increase this size. And increasing the size increases the resolution. All right, so that's good. So we're up to 383 megabytes for this matrix. So that's a good size for me on my computer. I'm on a MacBook Pro with an M1 Pro chip, 10 CPU cores, 16 GPU, 32 gigs of memory. So that's kind of the machine I'm working with, and with these parameters, I find that a matrix around this size is usually where I can max out the resolution of the final render, where it still takes about a manageable amount of time, which to me is between 1 and 2 hours. So now you can see this takes a lot longer to render because it's a much larger matrix than what we were just dealing with. Oh, and I just realized I made a mistake. I did not change the Z value back. So I increased the resolution by a factor of 8. I went from 1,000 to 8,000 here. And this value determines the width height values. So I increased it by a factor of 8, but I forgot to change the Z variable by a factor of 8. So what that means is this is going to show up like it's a flat map. And it's hard to stop the process once it's started. I'm trying to hit escape here and it doesn't work. I could hit stop several times and that would give me the option to restart R, but I don't want to do that because I'd have to load the data again. There we go. Okay. Yeah, and it's closed. So now all we need to do is render it again. We need to create the object again. Okay, there we go. It is finished rendering. So now we can adjust our object. See if we can zoom it in a little bit more, because however much we're able to zoom in, that's better resolution we're going to get. We could avoid zooming right now and then just plan to crop it after the fact, but that's going to hurt our resolution at the end of the day. So let's go ahead and zoom it like that as much as we can. All right, so now I think we're ready to get back to this. So I'm going to change these back. I'm going to up the samples to 450 and increase this back to 8,000 by 8,000. So all of that is just going to increase the resolution of this final image. And now let's render. All right, this is probably going to take over an hour to render, so I will leave it here and I will be back tomorrow. As you can see, it is after 9 p.m. where I am, so I'm going to go to bed and I'll finish this tomorrow morning. And we're back. Now, let me bring you up to speed on what happened last night. I woke up a little before 2 a.m. and I checked on my render and I found it had crashed my R session. So I had to restart the render. So you'll see here that the start time was 1:55 a.m. this morning. And this time it completed though. So we had a successful render. It took about 1.4 hours to render. That's what this is telling us. And so now we're ready to move on to the next steps. So let's take a look at the render. Here I'm looking at the subdirectory that we created for our images of the Seine population density. So I'm in the images folder and then the Seine subfolder. We have the first one we created. This is the low res version, as you can see. And I had it named the wrong name there, but here if we look at the other version, ta-da! So this is our high-res version. This is the final render that we were going for. And you say high-res, this is what I'm talking about. You can zoom way in and you can make out a lot of details still. This is why we increase the size of the image to 8,000 by 8,000 and also up the sample size in our render high quality call. And here, another thing I'd point out is you can see, like I said, I offset the two light sources a little bit so that you get this shadow effect. So you can see you have one shadow kind of going this way, that's our yellowish color, and one shadow kind of going off in this direction, and that's our purplish color. I think that's just a nice aesthetic. And if we look back over here, that's what we were doing with these arguments. So these are degrees of rotation. And there are two of them because I'm adding a white light also. The white light has an effect of dampening the shadows a little bit so they're not so heavily contrasted. Okay, so now we're done rendering, so we can go ahead and clear some things out. We can close that. We can go ahead and clear our whole session and close all of those. Command-Shift-W will close all your windows if you're unaware, or Control-Shift-W if you're on a Windows machine. Now, like I said at the beginning of this video, I use the new portrait function, to create the necessary framework within this directory to help me out here. So what that did is it created, for instance, this folder, and it created the rendergraphic.r script. It also created this markup script. And so this markup script is where I'm going to add my annotations to the file. There are just a couple places where I want to change the output file names. Okay. So here we're loading in the header, which just has some useful information, like the map name, the palette, the colors, and so on. And so we can assign the colors, assign a text color. So I'm assigning it to this first color here, the darkest color. Now we need to read in our file using image magic through the magic R package. And this is a general descriptive annotation that I add to all of these plots. Just provides a little information. Since this is the Seine, which is in Europe, they don't use miles. Do I want to include the miles? Let's drop the miles. Let's call it 40. Try 35. Well, I don't even know where I'm going to place these on the image yet. Okay, so next up, we're going to crop this image, and we crop it so that it just gives it a little bit more of a zoomed in effect. So I usually crop these as much as I can without hurting the graphic itself. So we can see there's a lot of room up here on the top of the image. There's a lot of room down here. There's not a lot of room side to side. So I think I'm going to maintain the 8,000 pixel width, but I could probably take this down. I could probably take 2,000 or 3,000 pixels off that. And so we do that here. So 8,000 will be our width. And then let's go down to, let's try 5,000. So that'll take 3,000 pixels off. And we'll just see where that leaves us. I'm just gonna, so I have this all piped together, and you can see it starts with the base image. It crops that image. These are all image magic functions from the magic package. So it crops the image, then we're adding an annotation, which is the title. And then I'm adding another annotation, which is this annote object. That's the description. And then these next two are the credit annotations. So the data source and the graphic credit to me. And then finally, image write saves our image. So you can run this whole chunk and it'll do all of that. And then we should see it come up in our handy images Seine folder. And it's titled Seine Pop. Titled Seine Pop. All right. So you can see we've cut off the image here a little bit. I don't want to do that. So I could move it down a little bit. I'm going to try to put the Seine population density. I'm going to put the title over here. I'm going to move this annotation over here. And we'll see what that does us. So if we say 5,500, and since I can see that there's still some room up here, I want to move it. I want to adjust the crop down. And you can do that by by adding a plus 500 there. I found this syntax to be not at all intuitive when I first started working with ImageMagick. So you really you get used to it as you use it. So I'd encourage you to play around with it yourself if you're unfamiliar. And then I want to move the title to the right side, so I can do that by switching it to the northeast. The annotation, let's put that in the southwest. Actually, let's put that in the west. Okay, let's see what that does. I've had people ask me before why I bother adding annotations like this. It can be a little tedious. Why don't I just use some sort of graphical editor where I can just type in some text and drag and drop and get it how I want? And my response is, I personally just like to have everything scripted out. That makes it much more reproducible on my end if I need to come through and make like minor edits to it. And also if I want to, like these are a series of very similar graphics that I make. So it's really not that hard for me to just come through and edit these annotations like this until I get it the way I want. But at the end of the day, I recognize it is a matter of preference. If you would prefer to go through and just add your text box here and, you know, use drag and drop tools, more power to you. Okay. I think I want to tighten this up a little bit. Let's see if we can bring that in a smidge. And I think this actually can stay at 5,000, just as long as we have the 500 pixel offset there. Let's see, I still don't love these annotations. What if something else I do sometimes is I will break this up into 2 lines. I don't technically need glue here. Oops. Let's make this like 400. So I'm going to make sin, the word sin, very big. And then below that, I'm going to put population density in smaller letters, all caps. So that's plus 200 plus 100. When I do this, I want to center it at the north, actually, so that it all is justified to the center. Okay, so that crop is pretty good. I'm happy with that crop. So then if I have sin population density, the gravity is coming from the north. So then I want to put it, there are 4,000 pixels going this way. So let's say 2,000 pixels. Or no, there's not 4,000. There's, okay, so let's add 1,500 pixels. And let's add 500. Same here, 1,500, 200. And then let's add 400 pixel difference between the two. See what that does. So if we do that, I think that'll look good for the title. That just leaves this. What if, all right, I'm going to switch this population density, and then I'm going to say along the sin. I think that could be smaller. Okay, I'm getting new thoughts now. What if I move the title over here? I keep all of the annotations below the graphic, so I could put the title over here, move this over here, change this to a single line. Let's see what that does for us. Whew. Okay, let's change this to a single line. Let's move the annotation over, like I said. This is probably going to want to go up more, so let's do 1,000. 0, let's see where that leaves us. This population density along, I want population density to be larger. So I'm going to make it 200, and then we can keep along the 150. Is it weird to call it the river Seine? Don't people say that? The River Seine, a Paris guide. You know, I have a background in French, so it's weird that I'm looking this up. Whatever. We'll call it artistic license. All right, that's going to be all messed up because I didn't do this. We want to go the other way with all of these. So plus 1,000 plus, let's call it 400 plus 700. Actually, that needs to be more. So let's say plus 1,000 plus 1,300 plus what, 2,000? Oh, this annotation's all messed up. That doesn't make sense. We didn't go far enough over, so let's move it over 500 more. Okay, so we'll move that over. We need to go down more. So let's call it 3,000. Let's call it 2,000. Let's call it 2,300. All right, this map shows the population density along within 25 kilometers of the Seine. Okay, let's move this. I kind of want it down here, so let's move it over 500 more. So 2,500, 2,500, 2,500. Let's move it down slightly. Let's call it 300, 600. And then can we go 2900, see what that does? All right, let's see what that does. Again, this process is a little tedious, but I don't hate it. I don't know what that says about me, but if you find this not to your liking, by all means, you can annotate your graphics however you choose. Okay, so now I think I moved it too far that way. So let's go over back a little bit. Let's move the river Seine up a little bit. Okay, river Seine, let's go. All right, let's make it 250. 250. And I don't know what to do with this annotation. Do we want it? Maybe we should put it up here. It's probably bad graphic design. So let's nestle it in over here a little bit. Okay, annotation, we have it south plus 1000. Let's call it plus 2000. I'll put it over here. Or no, it won't. 750. That's how high up it's going. Plus 1000. And we're close now. I think that this looks good. Population density along the river Seine. This is one of those times where I want to be second guessing myself that I spelled that correctly. Population density along the river Seine. Okay, this map shows population density within 25 kilometers of the Seine. Population estimates are bucketed into 400-meter hexagons. There needs to be a space there, but I corrected that. So when we do this again, it'll fix it. What if I align this directly below that and then move this to the center? Let's try that. So change the gravity to south. So annotation, we want to go minus 2250. I think that looks pretty good. Wait, I did not fix that yet. We still don't have that space there. Ooh, that changed how that looks. I'm not sure how I feel about that. Let's play around with this and see. Say what the Googles. Okay, that looks pretty good. We can move it up a little bit now that it's a line shorter. Let's move it up 200. The Seine. Well, you know, Wikipedia is calling it the River Seine, so good enough for me. Population density along the River Seine. This map shows population density within 25 kilometers of the Seine. Population estimates are bucketed into 400-meter hexagons. Graphic by Spencer Sheen at Mr. Peckner's. Contour population data released June 30th, 2022. All right, I think we are done. All that's left to do is save that. And I will be adding this. Well, why don't I just complete the process here? So the next thing to do is to scale. I create a smaller version of this image because the one that we've created here, the full res version, full resolution, is really large. So that's 77 megabytes. And if you want to post on something on a platform like Reddit, they have a 20 megabyte limit. So I try to create a scaled image that will fit those limitations as well. And you can do this. So we just created this image here at this file path. So we're going to read it in. We'll read in the titled image. All we need to do is to scale it, and then you create another image. So I just call it a small version. And since 20 megabytes is what I'm shooting for, I'm going to aim to get as close to that while staying under it as I can. Also, I do not track the files in the images subfolder. I only track the images that are in my tracked graphics folder. That just makes things easier with GitHub. So there it's 16 megabytes, so I can go bigger than that, maybe 55. And the reason I want to be as close to 20 megabytes as possible is just to maintain as much of the image quality as I can. All right, 57. Could probably write a function to do this for me, but I haven't done that yet. There we go, 19.8. Whew, that's pretty good. All right, so let's save that file. Now I have my README file, which is on my main page of my GitHub repository along the River Seine. All right, now we just need to add everything. I should have committed before now probably, but oh well. I'm just gonna do it all at once. And there we go. Now let's check GitHub. Ray Shader portraits. And there she is. I think that one looks pretty cool. Pretty happy with it. So thanks for watching to the end of this video. Now I'm gonna go post this on Twitter and edit the video so I can share it on YouTube. Hope you enjoyed. Leave comments if you have questions. Like and subscribe to my channel if you wanna keep up with more videos like that.